Hello everyone, good morning. So we will wait for a few more minutes for other folks to join and then we will get
So, first of all, welcome everyone. I know it's a Saturday morning. I probably might be wanting to do something else in life, but we are here and we're going to learn. So, let's get started. So like Swati was introducing me, I'm Nikhil. I do work at Netscope as a senior engineer, and I primarily work on intrusion prevention systems. And there's a bunch of automation, there is network security detection content, and recently I've started doing a little bit of threat hunting as well. Um, but before Netscope, I was a full-time malware analyst, and what I'm going to be sharing with you today is my learnings that I've had from those job roles. So today are primarily, do you still see my slides moving, right? Don't see.
No, it is not moving. Yeah, now it is.
Is it? It is? Okay, awesome. Okay, cool. So there's a bit of a delay. So I'm just going to be talking a bit more slowly. Yeah. So a few weeks ago, so Swati and I were talking, and we had a goal of raising cybersecurity awareness in the community, and this webinar series is sort of the result of that conversation. And we all know that cyber attacks across the globe are on the rise, and the one aspect of it that I wanted to focus on is understanding malware and its detection part of it. So the
Nikhil,
way I'm going
just
to,
sorry to interrupt. It is saying
yeah,
stream paused. You have minimized your application. So maybe it will be better if you share the entire screen. That should be good if you are sharing something else.
better now.
Now it has removed. Like in between it said it's stream paused because you have minimized the window.
Okay, can you still see it now?
I can see, yeah, the slides are visible.
Okay, awesome. Yeah. So as I was saying, so the way I'm going to take this webinar forward is by leaning on the MITRE attack framework as a reference to explain sort of malware behavior and the measures to detect them. So we'll also be doing some malware reversing, but I'll keep it light so that everyone can follow along. So today's specific agenda is start off with a brief overview of MITRE attack for those of you who are not familiar with it and why it exists and how it is useful. And next, we'll look at why malware is still relevant. So, I think it was last year when a senior person told me that, that security against malware is sort of like a done deal with all the anti malware solutions that exist. But we'll see today why that's not really true. Why that's not really true, and we'll look at some reasons why. Lastly, we'll get into the core of this webinar series by diving into some malware, which is related to two MITRE attack tactics. We'll also have some interactive polls today. I'm trying something new here. So I'm using this platform called Slido to conduct live polls. Hopefully it works as expected. We'll see. So here's the URL that you would need to visit on your browser, and as and when the sort of the polls go live, you can pretty much see them. I've just posted it on the chat. So there's no need to log in or anything. It's completely anonymous. So you can answer however you wish like. So we'll first start off with MITRE attack. So we'll first start with a thought experiment. Okay, now think that you are a threat actor. You want to attack a particular organization and you want to steal their data. So that's your aim. So how do you go about doing this from the start to the end? And now again, there's no one right way to do it, whatever to achieve your goal, right? So you can just take 30 seconds, just think about how you will breach an organization and how you will steal their data. I'll just pause here for 30 seconds and you guys can just think about your approach to achieve this goal. Okay, so hopefully you had some ideas. So what now I'm going to share is a few tactics that were used by actual threat actors. I'm just going to be going over some of the threat blogs that have come up. Can you see the blog being shared, or do you still see the slides, Swati?
No, we can see both the screen. That's fine.
Okay, awesome. Okay, yeah. So, for example, with this particular group 72, the first thing that you would need to go about achieving this goal is how do you choose a target or how do you exploit that target? So, how do you get that first initial access, as it's called? So, for example, with this particular group, they're called Group 72, fancy name. So they have their own vulnerability research teams to figure out, if there are any vulnerabilities or if there are any weaknesses in public facing applications that they can exploit. So they found these particular ones, these particular CVs. So whenever they come across these CVs, whenever they're searching organizations which are vulnerable to these particular weaknesses, they will go and perform SQL injection as part of their attack. And also they may use any other exploit which is related to more CVs that they found. Okay, so that's the first thing that you would need to do to breach an organization. First to choose, and how do you get that initial access? So once, let's say that now you have breached the organization, now you're in the network. So now what do you do, right? So this other APT group is called T33. These guys, APT 33. APT, for those of you who don't know, means Advanced Persistent Threat. They are usually very sophisticated threat actors. They are also usually backed by government, by nations. So you'll hear lots about Russian APTs, Chinese APTs, US APTs, and all these APT groups. They're basically very sophisticated threat actors who can do basically a lot of damage if they get in. So yeah, so coming back to the thought experiment, right? So now you're in the network. Now what do you do? So what these guys did is once they got into the network, they actually used another vulnerability, CV270213, and they used a publicly available exploit to escalate their privileges. So when they got into the network, maybe they got in as a regular user, right? But they wanted higher privileges. So they became the administrator or system account. So they wanted to go to that higher privilege. So that's why these guys used this particular exploit to escalate their privileges so that they can do more damage. That's the second thing that threat act. Now, now you're inside, but what if the system is suddenly restarted? Right? Maybe some user restarted it, or maybe the IT team is performing maintenance. But whatever reason, the system has been restarted. And if the system is restarted, you will lose access as a threat actor, and you'll have to do all of these processes all over again. You need to exploit the CV again. You need to exploit this CV again. And the problem with doing that is organizations have defensive systems. Okay, so when you do repeated exploits, alerts will come up on the SOC analyst's dashboard. And if that looks weird to the SOC analyst, that may prompt an investigation, and that's not a good idea for you, right? So that's not a good outcome for you. So what threat actors did in the case of Agent Tesla, so Agent Tesla is actually a malware. So threat actors who use Agent Tesla, so what they did to establish what we call persistence. Persistence as in um, you establish certain malicious code on the system so that even if the system is restarted, you can still go back to that same system without having to go through all of the exploitation chain. So here, so these guys, to establish persistence, what they did was they dropped some malicious file into the autorun key, into the autorun registry key, right? So what they will do is they will drop somewhere on disk whatever their malware file is, and then they will set up an autorun registry key. Autorun basically means that whenever boot up your system, then your malware file, whatever is mentioned here, that will go and run for at that boot time. So let's say you have auto run, then there's also another called run key, and then there is run once key. So that's the specific registry keys that are used for this auto run stuff. So run means every time you boot up your computer. Run once means the first time you boot up your computer. First time you boot up your computer, it will run, and then it will delete itself. Right. So it will only run once. So that's what it basically means. So basically, this is one of the ways to establish persistence, so that even if your target's computer is restarted, you'll still be able to maintain access when that system comes back on. So now it's time for your, the final goal, right? You have breached an organization, you have escalated your privileges, you have established persistence, so now you can maintain your access. But now you need to go to your final goal, which is to steal credentials. So going back to, APT 33, we saw this immediately after it, where they used certain tools, proc dump, to dump the memory for LSAS process. For those of you who are not familiar with LSAS, LSAS is, I think the full form of that was Local Security Authority Subsystem Service. And what it basically is responsible for is user authentication on your Windows system. So every time you log in, chances are the process memory of this LSAS process will have your credential. So what they will do, threat actors, is they'll dump the memory process, the process memory of this LSAS process, and then they will exfiltrate that particular process memory, or they might run Mimikatz. This is another tool, by the way, it's also publicly. So they will use this Mimikatz tool, try and extract your passwords from that particular LSAS process. So now that you have your credentials, right, you have taken a process memory dump of this LSAS process, and you've run some tools on it. You've got your credentials. But now what you want to do is you want to take those credentials and you want to retrieve it, right? It is still on your target system. It is not on your server, right? It's not in your control yet. So what you do is you encrypt the data, maybe in some manner, XOR encryption, AES encryption. There's so many ways to encrypt. And then you exfiltrate it to your C2 server. A C2 basically means command and control. So it's a server that you as a threat actor control. It's called a C2 server. So now what you do is now you want to exfiltrate it to your C2, and here's one example. So these guys, let me open them. So these guys, which is APT 39, and they have different names, different organizations give them different names. It's one of the drawbacks of the cybersecurity industry, where the same threat actor will have different names from different organizations. It gets difficult to track sometimes. Let me see where are that C2, right? So what these guys do, APT 39, is they collect all the data of the victim, right? These credentials and something else also that you have collected. They encrypt it using something called an XOR encryption, and then they zip it, and then they exfiltrate it to their C2 server over port 80, which is HTTP traffic. So now what I want to do is I just want to ask you guys something. Yeah. So where is that slide? Go to. So just want to see if you guys can start it. Okay. Okay. Can you guys go to that particular link that I shared on the chat to see if you guys can see this particular poll, if it is online? And if you guys see it, if it is online, what is the better exfiltration option for a threat act? right? Is it better to go over standard protocols like HTTP, HTTPS on those particular ports, port 80 or port 443? Or is it better to choose a non-standard port, like maybe you're choosing some other port that is not usually used on an organization, like you're using port 8080, for example. For HTTP, you're using port 80T instead of just port 80. Or if you think both are good options, there's no preference as such. So far, most people have identified the first option. Some are also going with the second. There are also some who go with the third option. All completely fine. Okay. But if you are a threat actor, your preference would actually to go with the first option. Okay. And the reason for that is when you're in a organization, okay, let's say that you are a SOC analyst. Okay. When you're looking at your dashboards and when you're looking at all the network traffic that's going outside, um, there is so much traffic that is going outside of your organization over port 80 or port 443, right? HTTP or HTTPS. There's so much traffic going out. So even if there is one malicious traffic that's going out, it's actually quite difficult to identify that. So so as a kind of a analogy, what I like to compare it with is, let's say that you're running on the road and then there is a police person chasing you. Okay, and then you arrive at a fork. So now you can go left or right. On the left, you see there's a huge crowd, and on the right, it's an empty road. Okay, so where will you go to escape the police? So chances are you're going to take the left road so that you sort of blend into the crowd. And it's sort of the same logic that applies here, right? So malicious threat actors usually like to go and hide in the huge HTTP and HTTPS traffic that already exists in organizations' network traffic. So going on to the next slide. So now coming to something called a TTP, okay, MITRE ATT TTP. This is very commonly associated, and with a lot of blogs, you'll see this particular acronym. So for those of you who don't know what MITRE means, so MITRE is basically a US non-profit organization. Um, so you can just get sort of a refresher here. So they were basically sort of spun off from the military kind of thing, but now they do a lot of cybersecurity um, projects, like large scale projects, and they do some other large scale things as well. So this particular attack, this MITRE attack, okay, so this is basically a large knowledge base. So this is that URL. So this is how the MITRE attack website looks like. And you'll see there's these different things, tactics, techniques, defenses, CTI is, I guess, cyber threat intelligence. So about different groups they'll have lots of information. So these are all threat actor groups that they have information for. So this particular acronym TTP, okay, so that TTP is basically something that originates again from the military, where the T stands for tactic. So what is the threat actor wanting to achieve? Like, are they studying your network? Are they trying to get in? Have they got in already and are trying to exfiltrate data? So what is it that they are trying to achieve? Okay, so that's what is called as tactic. The second T in TTP is called technique. So how does the threat actor plan to achieve their tactic? So to get into your network, are they trying to exploit a vulnerability in a public facing application? Are they sending you phishing emails? So what is the technique that they're employing to achieve their tactic? And the P stands for procedures. So it is a particular implementation of a technique. For example, a few years ago, 2020, if I remember, so threat actor called APT29, so they gained access to SolarWinds build server and Trojanized their Orion software. And Trojanized basically means when you have a benign software and then you inject sort of malicious code into that particular software, right? You Trojanize it. It again comes from the history, the Trojan War, and all that sort of references. Um, so basically, so this particular, compromise, it ended up spreading all over the world, and then thousands of organizations around the world were impacted because of uh, because of this uh, because of this particular procedure. And when you go to MITRE ATT&CK, you'll see something called supply chain compromise. So this is one of the techniques in the initial access tactic. Okay, so threat actor is trying to get into your network, and to get into your network, they have used this particular technique, supply chain compromise, which I just described with the SolarWinds software that got trojanized. So now the question is, why did MITRE ATT&CK why did people build this large scale project, right? So during our thought experiment, which we had just a few minutes back, so each of you thought about certain ways to breach an organization, right? You thought about certain TTPs, the way you would do it, right? So now let's say that all of you want to communicate that information to that organization's blue team. Okay, you want to say, hey, this is the way to breach your organization, so you should safeguard it. And here's the information you need to do that safeguarding. So in the end, the blue team will have a long list of your TTPs. Okay, and then they'll have to sort through it all and figure out where in the attack chain it fits into and what kind of mitigations they can put into place. So, mapping TTPs to specific threat actors, mapping TTPs to certain detection ways. So with MITRE ATT&CK, you can actually organize and standardize known tactics, techniques, and procedures. Okay, so for example, let's say you have two threat actors. Okay, let's say you have APT 33, and let's say you have another famous group called the Sandworm team. Okay. So how do you differentiate between their modus operandi such that you can easily communicate it to everyone? Okay. And that's where MITRE ATT&CK helps. So when you say something like, the Sandworm team uses X procedure to achieve a given technique and tactic, but APT 33 uses a different Y procedure to achieve a different technique for the same tactic. Okay, so now it is clear to everyone what you mean and where it fits in the overall attack process or kill chain. So now once you have identified a set of TTPs for a particular threat actor, you can also attribute a future attack to them when that same set of TTPs reappear. Okay, so when you go to MITRE ATT&CK's website and you see all of these techniques used, so you'll see all of these techniques here. In case some of these techniques, come up in a future compromise, right? You're trying to investigate what's happened, and then you come across all of these different techniques, and then you can sort of look at MITRE ATT&CK and say, oh, these techniques are associated with this particular threat actor. So maybe it is that particular threat actor who is trying to breach your organization, right? So that's where MITRE ATT&CK helps. One of the greatest benefits is to organize and standardize known tactics, techniques, and procedures. Now, as for detection and mitigation, you can use MITRE ATT&CK sort of as a reference. Like, for example, if I just click on this first one, um, so this is application layer protocol. So basically the threat actor is trying to communicate with their C2 server over, some protocol. So what you can do here to sort of, as a blue teamer, what you can do is you can implement certain mitigations. Like you can look at certain network traffic specifically, or you can have intrusion prevention systems and those kind of mitigations in place. So MITRE ATT&CK also gives you some information for different techniques of how to mitigate that particular one. So this was just application layer protocol, and there are also more sub techniques below it, by the way. So different ways to achieve the same application layer protocol technique. So if you go to credential access, we just go to that LSAS thing that we were discussing. Okay. So again, we were talking earlier about how a certain threat actor used the LSAS process memory to dump credentials. So this is that technique which is associated with that. Okay, so if you come down and see, you can see so many threat actors have used this particular technique. So if you go down, if you'll see a bunch of mitigations that you can put in place to either detect this particular technique being employed or to completely prevent it. Now with I guess just to reference Uncle Ben, um, with great power comes great responsibility, right? So when there's so much information in MITRE ATT&CK, people sometimes misinterpret it or misuse it. Okay, so attack is a large knowledge base, but it is not exhaustive, nor is it some kind of a law that a threat actor will follow. Okay. So whatever information you see in MITRE ATT&CK here, all of these on the left side, so these are TTPs that are, that are known, okay, that have been used in the past. It is not an exhaustive list. Okay, so tomorrow maybe there is some, that uh, maybe some threat researcher has found a new way to do process injection, right? And that technique is not here right now, but maybe there tomorrow. Okay, so basically attack is not exhaustive. Okay, it will be routinely updated as and when new techniques come into the picture. So what happens is when organizations are trying to figure out their security posture, they will perform something called threat modeling. Okay, and that will help them determine what their weak points are, and so that they can go and harden those particular weak points and like prioritize that process first. Now that's great. That is part of how you sort of close down your weak points. But threat actors don't care about that. Threat actors need just one point to breach an organization. It doesn't matter whether that particular technique that they've used is part of your threat model or not. Okay, that's irrelevant to a threat actor. So an organization should not assume that their threat models that they've built are exhaustive or something that the threat actor will follow. In other words, it is incorrect to assume that some attack techniques are more likely to be used by threat actors, and organizations will sometimes do this, to sort of to cut costs by hardening only against techniques in their threat model. But ideally, what organizations should do is use MITRE ATT&CK as a reference to determine all of their known exposed areas and then start prioritizing them and then harden them all in order, of course. Now, the second misinterpretation of MITRE ATT&CK is, again, like I was telling before, is to assume that it is some kind of an exhaustive list. So people will look at the process injection technique and say that, oh, there are 12 ways to do process injection. If we harden against these 12 techniques, it's a done deal and we are safe against process injection. That's not the case. Tomorrow there'll be some new technique and then you won't be safe against process injection. So now let's do another poll. Let me go back to our Slido. Okay. So this dot. So if you guys go back to that URL, now you should see a different poll sitting there. Now this should be about what is MITRE ATT&CK. So we talked about MITRE ATT&CK for the past few minutes. So what did you sort of understand from MITRE ATT&CK? However, it is not an exhaustive knowledge base of threat activity. So as we were talking about it, MITRE ATT&CK is a database of known tactics, techniques, and procedures. It is not a source of truth of everything that will possibly exist in the world. Okay. So tomorrow there might be some new technique for us. There might be some new way to achieve a technique, or there might be a new technique itself, and that will, that information will get updated in MITRE as and when it gets, public. So it is not an exhaustive knowledge base of threat actor GTPs. The third one is absolutely correct, that organizations should be using MITRE ATT&CK as a reference for threat modeling and creating detection code. Now, the fourth option here, that one was a trick question. So MITRE ATT&CK, if organizations can use MITRE ATT&CK as a reference, to build their defenses, threat actors can also use it as a reference to breach those organizations, right? So MITRE ATT&CK is not a law that threat actors will 100% follow, but they can still use it as a reference when they're trying to breach an organization.